All right. Hey there, guys. Happy Thursday to you. I know a lot of you guys got chances to work on the PFAs yesterday. Keep that up. That's good stuff. Okay. So we've come to what can be the tricky part of circles. Okay. And I'm going to try and do my best to explain it and then give you a nice, easy shortcut. Okay. So first, let's just read through this problem. Okay. A circle with radius of 15 is subdivided by a central angle. Okay. So let's define central angle. Okay. That is an angle made by two radii. Now, that might seem complicated, but I mean, if you think about it, it's just like if you have a circle, that is a central angle. Okay. And then obviously, like there can be lots of different types of, so there could be a much bigger central angle. Okay. So an angle that is made inside of a circle by two radii, that's a central angle. Okay. Now, the resulting arc length of the subtended arc, okay, on both of these, this section right here, those things, those little chunks of the edge of the circle, those are called subtended arcs. Okay, so arcs just go along the edge of the circle. And remember this, central angles subtend, and I like to think of the word cut. Oops, I was going to spell that wrong. They cut arcs. Okay, and arcs are just little segments of the outside of the circle. Right? Now, there's an important set of relationships here. Okay, and what I want you to notice is something really important. Okay, so let's talk about a central angle. A central angle is part of a whole. Now, you guys are actually much better at this than you already think. Okay, so let's say I draw that central angle, and I said, "Hey, if that's a fraction, what part of the whole is that?" Every single one of you, all of you, could tell me, "Oh, McSparron, this here, that's 1/4 of the circle. That is a part of the whole." Well, what you need to realize, and I'll bet you that most of you guys could also tell me this, that that angle, and now obviously it's not drawn perfect, right? But let's pretend if that's a right angle, then it is 90 out of the whole, which is 360. There's 360 degrees in a circle. Well, 90 out of 360 is reduced to 1/4. Okay, so the whole is always 360. So a central angle is just a chunk of that 360. You can't ever have a central angle that's more than 360 because there's only 360 degrees in a circle. Now, the thing that I also want you guys to realize here, okay, an arc is also part of a whole, right? So let's think now about this exact same one. And now let's focus on this arc. All right. Well, the whole, what do we call it if we go all the way around the outside of a circle? You guys all know that term. That's circumference. So if the whole is the circumference, then an arc is just part of the circumference. Now, in this case, what if I told you guys, all of you could get this? What if I told you that the circumference was 12? Well, what portion of, so here, maybe we can draw it out like this, right? So if I go all the way around the outside, what if I said the circumference was 12? All right. So then the question would be, what is that arc out of 12? Well, we all know that that's 1/4. And you guys could probably figure out that 1/4 of 12 is 3. So the length of that arc is 3 because it's a part of the whole. So we say all that just so that you recognize that both the central angle and the arc are both parts of the whole. Okay, now that we know that, here is my phone is buzzing like crazy. I don't know who lives in Argyle, Missouri. I don't know, prank call or something. Okay, so here is your shortcut trick. Okay, and this is the thing that you're going to write down, and then we're going to use it for this equation. Okay, so I'm going to say like write this down. This thing that I'm going to put here. Okay, so arc length is a part. Oops. The whole is the circumference. Now, we happen to have an equation for circumference. Circumference is 2 pi r. So instead of putting circumference on the bottom of that fraction, I'm going to put 2 pi r on the bottom of that fraction. Now, here's the cool thing, okay? Notice that for both of my examples, it's the same fraction. It's the same part out of the whole. So when we're dealing with arc length and central angle, the fractions have to be the same. So we're going to set up a proportion. I know you guys worked on proportions last semester with Miss Lee and Mr. Abundus, okay? But if you need a refresher, you're welcome to send emails or sign up for meetings with me and Mr. Hayden. Okay, that's fine. So arc length is part out of the whole. So that's arc length out of circumference. And then I'm going to have central angle is my part, and my whole now is 360. That's your equation. If you can plug pieces into that equation, you can solve any of these problems. Any of them, okay? So write this down. And hey, guys, when you're taking PFAs for us right now, there's nobody there to see whether you have notes next to you. Have this written down right next to you when you take the PFA. Write it on the wall. I don't care. Have this next to you. All right. Now, let's solve this problem. Okay. I know that I need arc length. Okay. So arc length is 10 pi. So right away, what I'm going to do is I'm going to take here. Let's do this. I'm going to give myself a little space. We're going to bump all that down. Perfect. Mostly perfect. All right. And here's what I'm going to do. I'm going to rewrite arc length over 2 pi r equals central angle over 360. Now, I'm going to plug the parts in. So if I know that my arc length is 10, I'm going to plug it in there. So watch, I've got 10 pi right there. Now, it gave me 15. That is my radius. So I'm going to take that 15 and watch where I put it. I take it and I put it right there in place of the radius. So now I've got 2 times pi times 15. Okay. Now, it's asking me what's the measure of my central angle. So that's my need to know. Okay, so need to know, I could leave it as the word central angle. I'm going to go ahead and replace it with an X because that's going to make the algebra a little bit easier on me, okay? Over 360. Now, I want to show you guys a trick, okay? Make your life a little bit easier. You want to simplify this before we cross multiply. Ultimately, you're going to need to cross multiply. But first, let's simplify. Okay, so I'm actually, I didn't move this down far enough. I need to move it down farther. Take all that way down here. It's still there in the notes. Okay. All right, so we're going to simplify. What we can do first, get this pesky pi out of there. If there's a pi on top and there's a pi on bottom, cancel them out. Okay. Now, I know that I've got 10 on top, and 2 times 15 is 30. All right. And then that equals x over 360. Okay. Simplify again. Keep your life simple. I can divide 10 by 10 and I can divide 30 by 10. I'll draw it out. Most of you guys won't need to draw it out. I can divide them both by 10, and that's going to give me 1/3 equals x over 360. Okay, now, I know that a lot of you guys will just multiply both sides by 360. I'm going to show you the cross multiply method just so that you kind of have it in your back pocket in case you need to solve for radius. All right, so I'm going to go top times bottom. So that's 1 times 360 equals bottom times top, 3 times x. Now, that's a pretty easy simplification there. That's just 360 equals 3x. I'm trying to get x by itself, so to undo the x, I have to divide, or sorry, to undo the 3, I have to divide. So I divide both sides by 3, and I get 120 equals x. And that, friends, is my final answer. That's my central angle. And I do that right there. I know that's a lot. I know it is. Okay? You have one homework problem. Just try it. I'm going to look at it. Mr. Hayden's going to look at it. We're going to give you feedback. If you're still struggling with that, please let us know. Okay? We can provide plenty of help. I know that this is a new process. I know it feels a little bit tricky, but give it a try. Okay? Don't panic and say it looks too hard. All right, that's all I've got. Have a fantastic Thursday, and let me know if you need anything from me.